Okay, Java was developed by Sun Microsystems for embedded devices in the early 1990s. So at the time, Sun Microsystems thought people were ready for smart toasters and intelligent refrigerators. Sadly, however, they were not. And these were devices that might not have had sophisticated operating systems. So the idea was the JVM was supposed to be a stand-in for any device that didn't have a solid operating system. Okay, so the world did not want smart toasters in the mid-90s, and I don't think the world really wants them right now. So the language almost died because of a lack of demand until people realized you could put a JVM in a web browser and run Java bytecode downloaded from the web. Okay, what this did, this provided executable web pages in the early days of the static web. So in 1995, this was absolutely revolutionary, because before then, all web pages were static and boring. So in, say, pre-1995, we did have the web. So the web, we have web browsers. And web browsers talk to web servers. Okay. And basically the web browser makes a request for a web page. The web server goes and finds a particular file. So the request is called an HTTP request. The server finds a particular file. Okay, and then the server will send that file back, or the contents of that file, in this thing called an HTTP response. Okay. And then what would happen next is the browser would interpret the contents of the file. So the contents of the file were HTML. And HTML is a language that allows you to specify how you want things drawn on the screen. Okay, but what happened in 1995 is we figured out, well, we can put a JVM inside a web browser. And we can still make a request to a web server. Okay. Okay, but now, in addition to HTML, okay, what the web server would send back is some bytecode. And if the web browser has this JVM embedded inside it, the web browser could then execute this code that came from a web server. Okay, and we call these things Java applets. You may have heard of this term, a Java applet. They still exist in web pages today, but they're not the dominant way to have an active web experience. In 1995, sending the bytecode to the JVM was really the only way to not have a static, plain old web page. Okay, so there are some pros and cons to this approach. The benefits are, for one, there are no manual installs of software. If you want the latest version of a web app, you just pointed your browser at the same page you went to yesterday, and you downloaded the updated bytecode. This cut down on the effort to roll out new software to clients. So in the old days, we had IT people who would literally walk around to every single machine, and they'd be responsible for installing new software. And this was really hard. For these IT people, when they came to your machine, they basically would ask you to give up your machine so they could perform the install. And not everyone was willing to give up their machines, even for a few minutes. Or, someone would be on vacation and the IT team would have a hard time getting new software installed on 100% of the machines. It was just, in general, kind of a big headache. Another pro is that bug fixes and updates were localized to a single server. Okay, so if you have some new code or you fix a bug, you just update that server once, and every single one of your clients sees the latest and greatest. Another benefit of Java applets is Java code can be sandboxed. Okay, so when running code downloaded from the web, the JVM can limit what that code can do to your machine. For example, it could limit it so that the bytecode cannot write to your file system. But the applet could still talk to the server who supplied the bytecode. So you could have this communication between client and server without running the risk of infecting the client machines. There's no way with a sandboxed Java program that it could possibly infect your system. Now the drawbacks are we had much larger downloads. Right, so not only are we downloading HTML, but now we have to download this bytecode as well. And this was a really big problem in the mid to late 1990s because our networks were so slow. Ultimately, this was too much to overcome, and we sought alternatives to the Java applet. We looked for different technologies to make a more active web. So we learned that Java programs are compiled into bytecode and then interpreted. We also learned this platform independence came at a cost. It takes processing power for the JVM to translate the bytecode. However, today this is an acceptable trade-off because our hardware is so much better than it was a decade or more ago. So today Java is run on the desktop and maybe more importantly on web servers.